Okay, so in the last lecture, I have given you so many examples of the uniform circular motion. Few more examples on the uniform circular motion, which is asked generally the motion of the car on the rough horizontal surface, right? You may write motion of car on rough horizontal surface, right? Horizontal circular track, circular track, rough horizontal circular track. Suppose this is the circular track, right? And this is the radius, and there is a car. Is it clear or not? And this car is moving with the speed v on this circular track like this. So can you tell me how many force will act upon this? Yes, the mg and the normal reaction, and any other force? Friction. What is the direction of the friction? In the first direction or in the second direction it will act? You tell. We are considering the UCM. Tell me, what will be the direction of the friction? First or second? Listen one thing. Okay. And other Varsha, what you will tell? Suppose this is the side view. I am making the top view, right? This is the mg is acting, normal is acting in the upward direction. So where the friction will be acting on this car? You tell. Listen one thing. Listen. The friction is acting towards the center. This is the correct direction. Why? Because when a particle is moving in a circular motion, there is something required, some force is required towards the center. If you apply, the mg is acting into the board, the normal is like this, mg is like this, normal is like this. So if friction is acting in this way, so what is the net force towards the center which will provide the required centripetal force? Right? So this is not the direction, rather friction should be into the board, towards the center, and this friction will provide required centripetal force. This is the direction. I will give you few more examples so that you can understand. Are you getting or not? So what is the net force toward the center? Net force towards center. Tell me, what is the net force towards center? Say is equal to friction. So it will provide the required centripetal force. Is it clear or not? So the net force toward the center is what? Say friction is equal to mv square. Are you getting or not? So listen one thing. When the car is moving, the friction between the tire of the car and the road is the static friction, right? So this friction is nothing but the static friction, right? So Fs is equal to mv square upon r. Are you getting or not? You tell me. If the car is stationary on the road, so if the car is stationary, if car is at rest on the road, on circular track, you can say circular track, can you tell me what will be the static friction value? Say 0. This is the static friction is self-adjustable. If car is at rest on a circular track, if the car is at rest, how many force will act upon this? mg and the normal. That's it. When it will try to move in a circular track, the friction start acting between the tires of the car and the road towards the center of the circle. So this is the static friction, right? So also from this formula, if the v is equal to 0, the static friction value is what? 0. The static friction is what? 0. So as you are moving, if you are increasing the speed, the static friction is self-adjustable, you know, and its value will increasing continuously. Are you getting or not? But what is the maximum available friction? What is the maximum available friction? The maximum available friction is mu into n. Say mu into mg. Are you getting or not? So if you think the v square is equal to r into fs upon m, so the speed depends upon this friction available. As much as the static friction is acting, the speed may be increased, right? Or you can say, if the speed is increasing, the value of the static friction is increasing. If it is at rest, it is 0. But for the maximum value of the, for maximum speed, right? Maximum speed, the friction, this friction will become equal to Fs max. So in this case, mu mg is equal to m into V max square upon r. So mm will cancel out, mu rg is equal to V max square. So what is the maximum speed of this car without skidding on the horizontal circular track is root mu rg. Are you getting or not? Listen one more thing. If I ask you, if there is a floor on your room, and if you spread the oil on your floor, and then I ask you to make a circular turn on your floor, can you do that? No. What will happen? You will slip, right? So it is very necessary, the friction is very necessary if you want to move in a circle on a circular track. Are you getting? Without friction, motion is not possible. Are you getting or not? Right. One more thing. This is the maximum speed. Whose maximum speed? By which a car can be motion, circular motion, uniform circular motion without skidding. Right. If the friction coefficient is less, the maximum allowable speed without skidding will be small. Are you getting or not? As much as it is rough, the maximum allowable speed without skidding is the more. You understand this or not? So what is the maximum speed on the circular track which is possible without skidding depends upon the friction coefficient between the tire and the rod and the radius of curvature. If radius of the circular track is small, then again the maximum speed will be less, will be small, right, without skidding. So do you understand this thing? Right. So this is the important point. This is the static friction. This friction is nothing but static friction, and this is self-adjustable. Self-adjustable. And what is the maximum available friction? This is maximum available friction. Available friction. Mu mg. Are you getting? If no movement, the static friction is 0. The maximum friction is this. For that, the maximum allowable speed of the car on the circular track without skidding is root mu rg. You have to remember and understand, right? Copy this. Yes, please. Okay, very good. Listen one thing. The rolling friction, when we discuss the rolling friction, or we will discussing in this the rotational motion, the rolling friction is the static friction. If you consider the tire of the car, right, or the rim, or the tire of your cycle, right, so this is moving with speed omega and it is moving with v. So this point is on the ground, right, and this point on the car, right. There is no relative motion between these 2 points. So when there is no relative motion between the surface in the contact, the friction is nothing but the static friction. Are you getting? This concept we will discuss in the rotational motion in the upcoming chapters. So for now, you can remember that if a circular body is rolling on the ground, for example, this is the pen, it is moving, it is a rotational motion and rolling motion, you can say. So the friction acting between the hand and this pen is the static friction. Although the body is moving, but I will explain in the rotational motion then that these 2 points are at rest. There is no relative motion. Its speed is also 0, its speed is also 0, because it is ground, it is also 0. This is the velocity of center of mass, this is the 2 VCM, and the different parts are moving on the circular object with the different velocity, but it is not a part of this discussion. We will explain this in the rotational motion. For now, you can just remember this, right? So that is the concept, right? So listen one thing. If you want to increase the maximum speed, the allowed maximum speed on the circular track, so what you have to do, you tell me. if you want to increase the speed on the circular track, suppose the traffic is more, right? So if the speed is less, there will be the traffic problem in the on the signal on the circular track. So what you have to do, you want to increase the on the some, you can suppose in a some circular track, right, the maximum speed is only 10 kilometer per hour. Are you getting or not? You want to increase this speed, so what will you do? You tell. Yes, one thing is, one possibility to increase the radius of the circular track, but in our cities there is a space is available in a limited space is available. So we want we cannot the increase. If we increase the friction force between the tire and the rod, right, will increase, and they can the burst the tires, they can damage the tires of the cars. Understood? So neither I want to increase the friction coefficient and radius also. So what to do? There is another technique. Without increasing the friction coefficient and without increasing the radius of the circular path, we can increase this maximum allowable speed on the circular track, and that is called the banking of the road, right? Banking of the road. To increase this banking of road, to increase this speed, we will bank the road. What is the banking of the road? Can anyone explain you? Any one of you? What is the banking? Tell. Yes, tilting the road. Yes, suppose there is a road and this is a circular track. So what we will do? The outer edge of the road a little bit raised. This outer edge is raised by some height with respect to the inner edge. Are you getting or not? So then what happened with the due to this? Suppose this is the angle theta and there is a car. Are you getting? And it is rotating in a circular track like this. Suppose this is the radius. Are you getting? So how many force will act upon this? Say mg, the normal, right, and the friction. Is it clear or not? When it was the level, so friction was acting where? In this direction along the radius. Now the friction will act along the incline of the road. This angle is not like 30 degree 40 degree. This angle is the 5 degree 10 degree in practical application. You can see practically in a circular track, or when you sit in the train, sometime in the train or the big highway, when there is a circular track, the road is raised, the outer edge of the road is raised with respect to the inner one. Have you seen this? Right, you can observe in your city also sometimes in circular track, not a small circular track on the big road it is. So now if the radius of the circular track is r, right, so you tell me how to resolve this force. I have given you the two statement. The force you have to resolve. Listen one thing, the centripetal force is nothing a force, rather it is obtained by some other force. Do you understand or not? And you have to resolve all the force. How to resolve these forces? You have to resolve the forces along the radius and perpendicular to the radius. Is it clear or not? Otherwise you will resolve, this is the theta, this is mg cos theta, and this is mg sin theta. It looks very simple and attractive, but it is not like this. So we have to resolve, this is the mg and this is the radius vector. So mg is in the correct direction, so there is no need to resolve this. Rather what you have to resolve, if this is n, this is theta, yes, this is what, say n cos theta, and this is what, say n sin theta. Is it clear or not? Also this friction, this is the friction which is acting in this direction. If this is theta, this is the radius, right, this is theta, this is fr cos theta, and this is what, say fr sin theta. Is it clear or not? And this point I can assume this, wait for 1 minute, this is fr cos theta, this is n cos theta, and in this direction the n sin theta was also acting. Are you getting? And also in this direction the mg is acting. Are you getting or not? This is the center of the circle, you assume. This is the radius. So what is the net force toward the center? Net force towards center. Can you tell me? Will provide, yes, very good. And net force toward the center will provide require centripetal force. Centripetal force. So what is the net force toward the center? It is Fr n sin theta plus Fr cos theta is equal to what? Say mv square upon r if speed is v on the circular track, right? This is the equation number 1. And in the vertical plane, suppose this is the x direction, this is the y direction, right? I am writing this is the equation in x direction. Now in y direction, what you will write? In the y direction, the mass of this car is m and it is moving horizontally. No motion in vertical plane. So in y direction, the net force is what? Say 0. What does it mean? This is the n cos theta, this is the mg plus fr sin theta. What should be write the relation? This fr sin theta plus mg, or you will write the n cos theta will equal to mg plus fr sin theta. Is it clear or not? Copy this, copy. We can further simplify this. How? This is the n sin theta plus fr cos theta mv square upon n. It will come this side. N cos theta minus fr sin theta is equal to mg. Equation number 2 I will write. This is the equation number 1. If you divide the 1 by 2, this is the 1, n sin theta plus fr cos theta divided by n cos theta it is, plus minus fr sin theta, right? And this is the mv square divided by mg, right? So m will cancel out, v square upon rg this side, and this is the n sin theta plus fr cos theta, right, divided by n cos theta minus fr sin theta. Is it clear or not? So this is the speed again which depends upon the friction. This is the static friction again I am telling, and the static friction varies from 0 to mu into n, right? So to have the maximum value for maximum speed for Vmax, for V is equal to Vmax, for the maximum allowable speed, the friction must be equal to the mu into n. The mu m, it is not equal to mu mg. What is the maximum static friction? The available friction is mu into n. So I will put n sin theta plus mu into n cos theta over here. This is n cos theta minus mu n sin theta, and then this time the maximum speed into r into g, and then it will cancel out, also divided by the cos theta both side, the tan theta plus mu divided by 1 minus mu tan theta is equal to v square Vmax square upon rg, right? So Vmax is equal to, right, you may write multiply this rg tan theta mu plus tan theta upon 1 minus mu tan theta. This is the maximum safe speed, the maximum safe speed. Is it clear? On the banked road, on banked road. Is it clear or not? Yes. So this is the maximum safe speed on the banked road, right? So this formula you have to remember. Are you getting or not? There may be the possibility that this, listen, this speed depends, if this speed may vary from 0 to maximum speed. This speed is what? Say 0 to Vmax speed. Are you getting? As the maximum, as the speed is increasing, the friction will increasing, right? But there is a possibility you can turn this car without friction, right? Turning without friction, turning without friction, without friction also you can turn on the circular track. It is not possible to turn without friction on the horizontal track, It is not possible. How? Because mg and normal is there. There must be some force which should provide the required centripetal force. Without friction on the circular track, you cannot turn the car. But without friction, the to turn the car or the movement of the car on the circular track without friction, what you have to do? You have to bang the road like this. Are you getting or not? Like this. And this car can turn without friction. Are you getting how? This is mg and the normal, and no friction is available there. But in this case, this is the theta, this is the n cos theta, and this is what? Say n sin theta. In this case, which will provide the required centripetal force? The n sin theta. N sin theta will provide the required centripetal force, and this n cos theta will balance the weight of the car. So this is the equation number 1 and this is equation number 2. If you divide 1 and 2, the n sin theta upon n cos theta, right, is equal to v square upon rg, because everything to cancel out. This is the tan theta is equal to v square upon rg. So what is the v square? The v is equal to implies that v is equal to root rg tan theta. I am writing here. Is it clear or not? So this is the speed without friction. Speed without friction. Is it clear or not? The same speed can be found with the help of this expression also. If you put the mu is equal to 0 over here, right? So what is the maximum speed without friction? Say rg 0 plus tan theta upon 1 minus 0, right? I am putting the mu is equal to 0, friction is 0. So rg tan theta. So this is the safe speed, right? Safe speed without friction. Safe speed without friction. All right. Copy this. Either you can do by this, or in this formula from this speed you can find. So this is the maximum speed with friction on the bank rod, and this is the speed on the bank rod, maximum safe speed on the bank rod without friction. You have to remember. Also listen one more thing. There will be the minimum speed also. Are you getting the minimum speed? This is the very important. The maximum speed you will get, but sometimes they ask the minimum speed. The minimum speed, minimum safe speed you can write. Safe speed. What is the minimum safe speed you tell? On bank rod. On bank rod. What is that? Listen. If there is a banking, if this is the angle, so you tell me, if this is at rest, so it will come down because of its mg sin theta component, right? So if you remain stationary, then it will slide down. So you have to give minimum speed so that it can move, and it does not skid. So you have to give the minimum speed in this case. This is the maximum speed. When the maximum speed is over there, its tendency is to skid up. Skid up. Are you getting or not? If you increase the speed, this car, if you increase the speed maximum more than this speed, it will skid up on the inclined plane, right? But if you decrease the speed, right, for this is the minimum speed after which it will slide down. So its tendency is to skid up in this case, and therefore the friction will down. So its tendency to skid down, right? Skid down. Its tendency in this case for the minimum speed, and the friction will act in upward direction. Is it clear or not, you tell? Right? If you decrease the speed, then definitely it will skid down, and the friction will be acting in the upward direction. This is the mg again, and the normal force will be acting in this direction. Is it clear or not? So I'm making the figure over here. This is the mg, this is the normal, this is the theta, this is the n cos theta, this is the n sine theta, right? If this is the friction like this is the fr. So this is theta. So this component is what? Say fr cos theta. And this component is what? This is n cos theta. This is fr sine theta. Is it clear or not? So what is the net force toward the center? Can you tell? N, yes, n sine theta minus fr cos theta is equal to mv square upon r. And here the n cos theta, right, plus fr sine theta is equal to mg. This is the equation number 1, equation number 2. Now you will divide 1 and 2. Are you getting this figure? Very good. Now you can simplify to find the minimum speed expression. How? Divide 1 and 2. So this is n sine theta minus fr cos theta divided by n cos theta plus fr cos theta is equal to what? mv square upon r upon mg, right? This is v square upon rg. Again the friction will be equal to mu into n. You may write, right, the mu into n. So it is n sine theta minus mu into n cos theta divided by n cos theta plus mu into n cos theta is equal to v square upon rg. Is it okay? And then n will cancel out. The cos theta divided by cos theta, it is what? Tan theta minus mu upon 1 plus mu, this is fr sine theta. This is fr sine theta. So mu tan theta, v square upon rg. And the speed will be the minimum in this case, right? Rg. So v minimum in this case, the minimum speed will be equal to tan theta minus mu upon 1 plus mu tan theta. Is it clear or not? So this is the minimum speed. This is the minimum speed. So this is the maximum speed. The maximum speed is tan theta plus mu. You will write tan theta minus mu, and the minus you can check the relation, right? After, if the speed is less than this, the car will skid down. If v is less than v minimum, car will skid down. Skid down. If v is greater than v max, this is the v max, car will skid up. If v is equal to root rg tan theta, car will move without friction. Car will turn without friction. Without friction. This is the very important. All the three formulae are the very important, right? For the JEE Advanced, right? This question V minimum and the V maximum, including the car will turn without friction, both are, all three are very important, right? You have to understand by the question language which formula you have to use, right? Okay, so this is the question. Can you read the question? 7.48 it is. Yes. Right. A circular track has a radius 10 meter. If a vehicle goes average speed, the average speed is given as 18 km per hour. So first I will convert into the meter per second. The average speed of the turning car is 5 meter per second, and the radius of the circular track is 10 meter. What they are asking? The proper angle of banking they are asking, the tan theta, the theta. Which formula and how would you find? Is the friction is over there? You tell. No, it is not given. Friction is not given. Do you understand or not? So without friction you have to, and the angle of banking. So without friction, if you want to move in a circular track, what is the possibility? You have to bank the road. Are you getting or not? So at what angle, what is the angle of banking so that it may move in a circular track? How would you find? Say again, the tan theta is equal to v square upon rg. That is the formula we are going to use. Did you remember this? This is the mg, this is the normal. So n cos theta and n sin theta, the tan theta. So this is the very important case, right? The proper angle of banking without friction, and you want to move on a circular track. So tan theta is equal to v square upon rg. This is 5 square tan into 10. 25/100, it is 1/4, the tan theta. So what should be the angle of banking? Tan inverse 1/4 is the correct answer, right? Please tell. Can you read the next question? Any one of you, right? Hmm. Hmm. Okay. Hmm. Okay. So listen, there is a radius of 20 meter. It is banked for vehicle 36 kilometer per hour. For this is the question. The radius of 10 meter, and it is designed to move the vehicle with speed 18 kilometer per hour without skidding. So then therefore you have to bank the rod, right? In this case, the radius of the circular turn is 20 kilometer, and it is designed to move the car with 36 kilometer per hour without skidding. So you have to bank the road. This is the first part of the question. Hey, you will convert this 5 by 18, right? 18 दूनी 36, 10 kilometer, 10 meter per second. So this circular track is designed for 10 meter per second speed. So what is the theta? How to find? The tan theta, you will remember v square upon rg, right? So the v mean 10 square upon 20 into g, it is 100 into 200, it is 1/2, it is 0.5. So the tan theta value is 0.5. This is the first step of this question. Now if the coefficient of the friction, suppose this is the track, the coefficient of friction is 0.4 given. What are the possible speeds of vehicle? So it neither slips down nor skid up, right? So two speeds you have to tell, neither skid up nor skid down. So what the speed they are asking? Can you tell me? For the slip down, yes, slip down first, slip down. So the friction will be acting upward direction, it will slip down. So what is the asking? They are asking the v minimum. Say root rg tan theta, right, minus mu upon 1 plus tan theta into mu, right? And second thing, they are asking the skid up. So what they are asking? The maximum speed. The maximum speed is rg tan theta plus mu upon 1 minus mu tan theta. Is it clear or not? So you will put all the value here. What is r? It is 20 into tan. What is the tan theta? 0.5. What is the mu? 0.4. 1 plus 0.5 into 0.4. Are you getting? And in the Vmax, it is equal to what? 20 into tan theta is 0.5 plus 0.4, 1 minus 0.5 into 0.4. Is it clear or not? That is the thing. So I'm directly writing the calculation. This is the maximum speed is 15 meter per second, right? When you will calculate this, and this is tan root 1/6 meter per second. You can simplify this, the mathematical calculation. Is it clear or not?